Welcome to Catalyst, a program about people, ideas, issues, and conversations around them.
Welcome to Catalyst. I'm Doug Webster, your host of the STEM education series, Renewed Culture of Innovation. STEM stands for Science, Technology, Engineering, and Mathematics. This series was developed to discuss key issues around strengthening our STEM education capacity, leading up to a STEM conference being held at the Burlington Hilton, May 24 and 25. The STEM conference is sponsored by the Vermont Department of Education, National Science Foundation Centers of Excellence, and the National Association for Workforce Improvement. Today's episode is STEM Education Rebranded, engaging the mainstream in STEM education. And my guest is Dr. Karen Birch, Executive Director of Connecticut College of Technology, NextGeneration Manufacturing. Karen is the State Director of Connecticut's College of Technology, a Professor of Applied Science and Technology, and Executive Director of the Regional Center for Next Generation Manufacturing. She has developed seamless education pathways in engineering and technology, including 12 community colleges, 6 four-year colleges, and 17 career and technical centers. She has received numerous awards and over $12 million in federal grants. Welcome, Karen.
Thank you, Doug.
Karen, how do you define STEM education?
Well, I think you definitely identified the acronym in terms of programs that are focusing on career pathways that certainly address science, technology, education, and math. However, I think it's much bigger than that. What I see as really an objective of STEM education is to ensure that all students have an awareness of what STEM is about. So as much as we'd like to encourage students to pursue these as careers, I think all students, whether they're looking at liberal arts, business majors, or even allied health, need to have an awareness of what STEM really entails.
Yes. Now, what about STEAM, and we have other acronyms in
exactly.
there.
And I think that kind of expands what I was saying in terms of when we've taken STEM and added STEAM, we've actually added A, which addresses arts. So I think, again, when you take a look at a lot of areas of STEM education, in particular, when we look at manufacturing and design, there's a whole aspect of really having the ability to integrate the arts in terms of just trying to get a sense of what that's going to look like.
Okay. Now, what do you see as the biggest challenges in strengthening STEM education nationally and within our region?
Okay. I think part of it is that individuals don't necessarily understand what STEM education is about, what the career pathways are. Maybe a bigger challenge in some cases, just students' preparation for these particular career paths. In some cases, the math is a challenge because I think sometimes individuals still have the phobia that math is too hard. Yet I think the reality is many students probably can do the math and the science, especially if it's presented in applications to a particular project, as opposed to just trying to memorize equations and facts that are more theoretical in nature. So I think, again, it's just trying to maybe address how we teach STEM education a little bit differently so that it's not really the talking head, but it really has a lot more applications and hands-on classroom and laboratory, let's say, projects.
Yeah, project-based learning.
Exactly.
Problem-based learning. Can you
Exactly.
distinguish the difference between problem-based learning? Because a lot of educators will say, well, we do problem-based learning. Project-based learning would be a little
bit different.
Well,
I think right now you see that a lot on the radar screen. Everybody's talking about problem-based learning. PBL is kind of the acronym for that. And what does that really mean? Really, it's just hands-on. So you could probably go back and say that teachers in some cases maybe have done problem-based learning for years, especially more in some of the technical fields. Because I know that sometimes when I talk with a technology education teacher, they'll say that they'll be the first to say, I've been doing this forever, you know, so everybody thinks this is kind of a 21st century learning methodology, when in fact it probably has been around maybe even since Montessori. You know, when you think about it, when you're little, what do you do with little kids? You actually engage them and get them, you know, doing things and building things with Legos, etc. So I don't think it's that much different in many ways, but the connection that I know that we're doing significantly with some of our grants is trying to connect what we're teaching in the classroom to industry, so to real world experiences. So once again, students see the relevance of what they're learning. You know, and I can speak for myself in my education. You know, I did all the calculus, and often I said, I have no idea why I'm solving this equation or what it really means. Yet when I see how it could be used to design a bridge, or possibly be used in terms of some of the STEM solutions to problems that industry is facing, then you learn it automatically. It's not even a challenge anymore. Right.
Now, we mentioned next generation manufacturing. Can you describe what that is and what you do with it?
Okay. Next generation manufacturing actually was a term that we used when we first received our award from the National Science Foundation to establish a center. And what we were trying to get away from is, you know, the perception of manufacturing being dirty and greasy and pretty much piecemeal, kind of like what you might consider to be your grandfather or father's manufacturing. So manufacturing these days is very high tech, almost always in many cases might require some education after high school. Many of the rooms that I've visited that might be doing some manufacturing applications, you could eat off the floors, or almost like an operating room. So I think that we're trying to say, look, next generation manufacturing is very different than what you would think of the manufacturing in the industrial age.
In fact, we have a video clip. This is a 30-second clip that you put on the General Networks, right?
Yes, it was actually a commercial that we had throughout Connecticut and we're still showing it so that just everybody will see what manufacturing really is and how much it's changed.
Well, let's take a look at that.
Okay.
We manufacture that move our world.
We manufacture guitars that rock our world.
We manufacture fuel cells that make clean energy that powers our world.
There's a great future for young people in Connecticut manufacturing, and you can prepare for it at Connecticut's community colleges. Manufacturing, it's not what you think.
That's great.
Okay,
That's
great.
Yeah, maybe we can do a Vermont version of that someday.
Absolutely.
Huh?
It's certainly not unique to Connecticut.
Right, right. Now, as far as manufacturing in Connecticut, where were you 10 years ago compared to today?
I would probably say that 10 years ago, we still had a lot of the old manufacturing types of firms, and many of them have either gone out of business, or a lot of those types of manufacturing companies have been relocated to China. So people always say to me, manufacturing, how can you be promoting manufacturing? Isn't it all gone abroad? And the reality is what has stayed in Connecticut, in the region, and probably throughout the United States is the high-tech industries that really requires, as I mentioned previously, a much higher skill set.
Right, right. Now, high-tech industry, now, you're talking about more engineers as well.
Engineers as well. So I think it's, and we're always seeing, you know, even with the unemployment rates, there's still a strong need for both engineering technologies and engineers that, you know, really have the skill sets necessary for manufacturing.
All right. Now, what things have you done to increase the pipeline of individuals in STEM and manufacturing engineering within the project and, you know, within your work in Connecticut?
Well, I think we've had several approaches. One is certainly trying to change that perception of what manufacturing is about. So we've had a pretty aggressive marketing campaign, of which you saw a little snippet of the DVD. But more importantly, we've actually tried to have students involved in what we're calling expos, where we brought students through a series of what we're calling, or what we did call pods, and they would see a manufacturing process from start to finish. So they'd see first how you would have to design a particular product and how it would go through all the stages from start to finish. And then actually now we've added a lot of the green manufacturing, so they also understand the importance of recycling and the responsibility of companies for what happens to that product when it's no longer being used. So we've actually wanted to get students, into companies as well. So we've done some tours. We'd like to get them onto community college campuses so they can actually see what higher education entails, and also see some of our really state-of-the-art laboratory facilities where they can make a prototype of a particular product that might be designed as well. So I think, again, we're trying to engage students and not just send a bunch of literature that we hope that they read, but we want them to actually, be part of the solution in terms of changing that perception.
Now what about your work with industry in designing programs that industry needs? Can you say something about the certificates?
Absolutely.
And how many do you have?
Absolutely. We right now have 18 certificates. They're all for credit. So what's really nice about that is a student might say, geez, I'm not so sure I want to do an associate's degree and nevertheless a bachelor's degree. Yet I still would like to have that additional skills that I need to get into the workforce. Because I think that's an objective of ours as well. We would certainly like them to complete an associate's and or a bachelor's degree. Yet on the other hand, we also want them to be prepared to go into the workforce, and in some cases it needs to be much quicker than maybe somebody who has the time frame or doesn't have that 4-year time frame.
Now, what do we mean by a certificate?
Okay, a certificate usually is a concentration of 4 to 5 courses that have been identified by industry to, again, really complete. I'll give you some examples. Like, we have certificates in precision manufacturing, we have a certificate in plastics, one in fuel cells. So again, we have industry that comes to our institutions, to our colleges, and they'll say, look, we need a student who has some of these skills. These are exactly the competencies that we need you to be teaching them, and pretty much will be willing to hire them if they fulfill those requirements.
And is it difficult to set up the certificate
I would say
programs?
no. I would say it's pretty simple. Often too, we do it in concert with industry, so that again, we're trying to prepare these students for a job, and I can't say it's super difficult. I would say no.
Yeah, okay. Well, as far as kind of going back to the perception piece, what are some of the issues that you have to deal with around perception, in particular recruitment of women and minorities?
Perception is, I think, always going to be a challenge, no matter how we cut it. We've been actually doing our marketing campaign since 2006, and I still struggle with counselors who basically, again, see manufacturing as not a viable career path, and often don't really have really the exposure to what's happening in the real world. We also deal with parents. Parents sometimes are challenging, where we'll have students that go through an outreach program or an expo. They're all excited. I'll see them a week or two later, and they'll come back and say, oh, my parents like, no, you're not doing this. Uncle Charlie was laid off. I want you to basically be sure that you have a career that's going to be stable. So it's those types of changes that I think are difficult. Unemployment, what you see in the media often will highlight losses of jobs in companies that, again, might be manufacturing based. So we don't often see articles that tout the opportunities in manufacturing. So I think we're challenged with, really from the media, to just parents and counselors in terms of just supporting career paths in manufacturing.
Now, I understand you're offering a workshop on May 26th.
Correct.
This will be after the national conference that we will have or would have had. What are some of the elements that you would be covering within that workshop?
Okay, and again, that workshop is actually going to be targeting how to recruit underrepresented populations, which you identified early as basically young women as well as minority populations. And we find that some of the strategies certainly would be around, again, trying to present manufacturing in a scenario that is relevant to society. I can tell you that from my perspective, when we've engaged young women, and I'll give you a couple examples, we have some projects that are working with the Children's Medical Center, designing an apnea monitor for premature babies, definitely engaging all kinds of STEM courses and strategies. And the young women don't even know that they're doing STEM, and they're all excited because they're going to save a baby's life. So when you can, again, I think, bring in the relevance of what these students are learning and this humanitarian aspect, we're finding that that is helping a lot. Another aspect is team building. We're finding when we work with our students and help them work more effectively in teams, that once again it seems to engage students no matter what the gender is or what their ethnicity is. So that would be some of the examples.
Okay. Now, can you describe some products that have been developed out of the ATE, the Advanced Technological Education program, the Next Generation program?
Okay. We've had, again, I mentioned the marketing campaign. That's probably initially was a major initiative of ours, and I know that there's actually a video clip that you're going to be showing shortly.
Right.
You know,
right.
so
We
I
have
think
another one here.
That definitely was something that, and what we're really proud of with that particular series of scenarios, what we did is we went into companies and we actually filmed technicians, engineers that were working in real life scenarios, so there weren't actors and actresses, and showed really, again, in one case we had somebody who was a chef and then started working at Trump, and now he's actually talking about what it means to be a laser manufacturing technician, you know, and our particular video, it's on our website as well, has been used as a model for a number of other outreach initiatives, including the Society of Manufacturing Engineers.
Okay.
You know, so that's one of the, I think, products that we've actually developed and
you also
disseminated.
You do curriculum assessment and
Yes,
you know, all
across
kinds
the
of
board.
other things
Yes.
as well. But well, let's go ahead and take a look at that video now. This is about a, what, 5-minute video?
Yeah, it's about 5 minutes.
Okay, let's check it
sounds
out.
Great.
Imagine working in manufacturing today. Some young people not only imagine it, but they're doing it, and they're discovering a new high-tech world, from laser technology to biomanufacturing.
The biomedical field is a very wide field. My focus is mostly biomechanics and biodynamics.
The amount of things you can do with lasers is phenomenal. Everything from cutting steel to measuring telephone poles for rot.
You can basically build and design prototypes for orthopedics. You can also work in orthodontics area. Basically, you can do studies about hip implants, knee implants.
There's so many things you can do with lasers. I mean, the field is just growing and growing.
This is a lot of fun. It's true that there's not a lot, especially in the past, that there's not a lot of women interested in this field. But you can see now that it's growing.
Manufacturing today is not what you might think. It's clean, it's high-tech, and it's growing.
I see a lot of the companies that I visit and that I'm friends with getting busier, finding new markets for the products that they make.
The jobs are there. It's more sophisticated now. It's no longer I'm going to school to learn how to cut material or work a machine. It's how do I have to work with the technology that's going to control that.
Typically a computer is running the equipment, and what we're looking for from our employees today are people that can use their brain more than they can use their hands or feet. There's very little physical work involved.
Manufacturing is no longer just a man's field. Women are making a difference too.
Almost anything you do in manufacturing involves a team of people. These problems are never solved by one person in one way. It's always, you know, getting a group of people that are part of different stages of the process together. Those are really important skills that girls happen to, you know, have a lot of talent in, just naturally, the way that girls kind of work together.
With the right education, there are plenty of opportunities for young men and women interested in today's manufacturing.
I've been very impressed with the overall level of the people that are coming out of both technical high schools as well as community colleges and universities today. They seem to be much better prepared than people coming out of a high school or college in my day. For example, we've recently hired a number of young college graduates right out of engineering school and put them into jobs where they're making immediate contributions to our business.
You can begin working in a high-paying manufacturing job with an associate's degree from any of Connecticut's 12 community colleges. You can also transfer your earned credits to one of the Connecticut College of Technology's partner universities and continue your program as a junior. And if you think you aren't that good in math and science, don't let that stop you. Your local community college can help you strengthen those skills.
Nowadays, manufacturing jobs are not dirty, they're not repetitive, they're cutting edge, they're clean, they're very well controlled, very well managed environments. And if you're not sure if you want to do it or not, check it out.
Okay, well, that's great. That was great, Karen. Thanks for sharing that. We only got a few minutes here, but can you tell us where STEM education should be in the next 10 years?
Okay, I only have 4 minutes. Yeah. Okay, I think the challenges are in many cases that right now we have some really cutting edge fields that are part of STEM in manufacturing. For example, fuel cells, alternative energy is really on the radar screen as gas. As a matter of fact, I paid $4.20 per gallon down the street on my way here. So I think we're all much more sensitive to how can we get away from fossil fuels, and that's a huge area of manufacturing in STEM. Things like nanotechnology, a huge area of growth, and certainly the applications are endless. And I think right now, to be honest with you, there's going to be careers and industries that we haven't even thought of. You know, when I think of the advances in education, 10 years from now, I'm sure that there'll be, you know, just things being made and procedures and techniques that we don't even have a clue what that might be. But I think no matter how you cut it, the career opportunities at this point in time are fabulous. We have students that, you know, graduate with associate's degrees in our manufacturing and related technologies with salaries $40,000 and up, sometimes $55,000 and up. So I think that students don't realize that the jobs are there and really provide, I think, great opportunities in many ways.
Okay, great. Now, is there anything else you wanted to add?
Just as a summary,
summary.
Hopefully, you know, as the video said, check out our website. There's a lot of other little scenarios there that you might want to take a quick look at. We've actually have some news clips and all. That would be wonderful. And we would hope that if you're from the Vermont area, and even if you're not, you're going to come to the NAWI conference in May. We'll be there as well. But I think there's a lot of great presentations and really opportunities to really see what's going on in STEM education and some fabulous networking opportunities as well.
Okay, well, great. Then I believe that's all we have time for.
And
then thank you for coming.
Okay, and thank you. Thank you for inviting me.